Welcome to the next episode about Rx. Today we'll be discussing about how to use the query operators and really showing off the power of LINQ. So previously we've talked about how observables can be used to represent asynchronous data streams. But now that we have a common interface, we can bridge into this common world, we can actually use the observable interface in order to write queries. And that's what we'll be discussing today. So today we'll be discussing the LINQ aspect of Rx. So first of all, a number of the operators that exist for Rx actually allow you to construct observables. For example, if you want to construct the empty sequence, just like with enumerables, you can use the empty operator. And here it just actually has a asynchronous data stream that has a single message, which is the onCompleted message. Return is very similar. This one is not part of the standard sequence operators, but is very useful. It constructs a singleton sequence with the value that you specify and then the completed message. Throw creates an observable sequence that just has an error, an on-error message in it, and never creates an observable sequence that has nothing, no messages in it at all. And so it never returns. And it's actually pretty useful. Perhaps you can find a good example of that. All right, so we talked about how observables are asynchronous data streams. But because they're asynchronous data streams, of course, that means they're data streams. So let's focus on the data part first. So there's a number of operators that actually work across the data aspect of observables. So for example, I have this sequence here that has a bunch of different dots, these on next messages. Some are green and some are blue here, and we have a completed message. What we're going to do now is apply a filter that's going to filter out and only allow the green ones through, right? And so each of the on next messages is applied to this filter, and then of course the resulting stream looks identical, but just with the blue dots in this case removed. And so this is kind of an operator that works on the data aspect of the sequence. Another part of the asynchronous data streams is the asynchronous part, and the asynchronous part brings in the notion of time. So again, we have a sequence here. The same thing, we have some messages, on next messages, some are green or some are blue. But in this case, we don't care about the color of them. In this case, we care about the time. So for example, we might want to shift all of the messages by like 1 second, for example. And so what we can do is we can say delay. We can use a delay operator, which is not a standard sequence operator, because the standard sequence operators really have been designed originally for enumerables, which are synchronous data streams. And so now we've had this notion of time, and we say, hey, look, time shift each one of these messages by 1 second. And so we get the same stream, but just shift it over by 1 second.
It could be a good exercise for the viewers to actually implement delay on enumerable.
Yes, that's pretty good. So that's that, and I'm going to turn it over to Bart to actually show us a few operators.
Okay, so let's actually start with a .NET event again to have something concrete to put our finger on. Let's just create a new project. Oops, if I can get to the new project dialog. And let's again start from WinForms and use some mouse events this time. So in order to bridge to the .NET events, we've seen in the previous episode how to do that. So let's now basically import .NET events into an iObservable of point. So let's do observable again. Oops. And let's add a reference to system reactive, of course, which we have sitting here. And now I can do observable.from event pattern again. And now I will import mouse event args over here from the current form, which is this, and I will listen to the mouse moves. So as I do that, as we've seen before, I get event patterns of mouse event args, but I'm only interested in getting the points, and then I will do some filtering and some logic on top of those. So in order to get to those points, let's actually write a little query. I will do from the mouse move event in this particular event sequence. Let's actually select out mme dot. I can dot into event args, and as you can see, it's statically typed based on mouse event args. It's basically a generic event pattern of T. And so as you can see, I can get to X, Y, I can get to the location as well. So let's actually just import over here the location. As I do that, I basically will have an event sequence of system drawing points. So that's actually showing select being applied here. Now let's write some query on top of that. Let's actually call that PTS for points. Let's write a query that now filters the points based on some criteria. Like, do you have a good criterion for me?
First by sector.
First by sector, for example. So the first, quadrant of the form. Let's do that. So let's actually take a look at, doing from point in points. And now let's actually filter the point based on some criterion. Or I could say like the first diagonal line. We could actually use that, which is much closer to what you actually meant. So let's do where point x equals point y. Select the point, as you can see over here. So now the event will only come out of the resulting sequence when x and y are the same. It's on the first bisector through the origin of the form. So now that I actually have that, I can subscribe to that. And let's actually put the coordinates in the title bar of the form. So let's say point goes to this.text equals point.toString, and fingers crossed that there is some good toString implementation on system drawing point. So let's take a look whether this works. I can actually hover over the form, but nothing is happening here unless I actually hit the first bisector of the form. As you can see, I see the events coming out where x and y actually have the same value. So now, of course, I could also say, let's do something based on time. What about listening to the point events, but say, for example, I want to bundle them together in chunks of time. Let's basically count the number of times my mouse has moved within a 1 second window. So that's a complex, event processing query that doesn't quite exist in the standard query operators. So let's actually take a look at how to do something like that. So instead of using this one, let's actually do some statistical information on how much my mouse is actually moving within a certain window of time. So the way to do that is by using one of those fancy operators called buffer or window with time. So let's actually buffer the points here in chunks of 1 second. And so we'll actually see an iObservable coming out that collects all the points that have basically been recorded within the last second. So let's say that I want to buffer here based on time span from seconds 1. So what's the transformation that's happening here really? We go from an iObservable of point to an iObservable of iList of point, which actually fires only once a second, telling me that a new chunk of points is actually available. And so now that I have this whole sequence, I can actually do queries on top of those lists as well, the lists that actually exist within the buffers. So I can do something from buffer in those 1 second buffers that I have sitting here. I can actually select buffer dot, for example, count. And so now I have actually a sequence that fires every second at the end of every second the number of times that the points have changed within that buffer. And because buffer is just an IEnumerable, I could write some queries here like averages and other sorts of aggregation functions as well. So let's just keep it simple and actually figure out the number of times that my mouse has actually moved. So this is really count at this point, and I can just
you need to use the UI timer.
And I will use the UI timer, but let's actually run this and show what happens, right?
Sure.
Yep. So when I execute this thing, I'll actually do Ctrl F5 here. Actually here it's going, That's kind of interesting. And so when I move the mouse really quickly, you see, in the title bar, you see some number of times that my mouse has actually moved within the last second, and you see the timer going up and going down based on my mouse moves here. So you see this statistical information coming too. Now we actually expected some exception to happen here.
I guess
and I know because
the title, I guess, is fine to change or something.
But I think actually the problem is that I'm running Ctrl F5, which doesn't run on the debugger, and so the thing doesn't barf. But in the next episode, when we talk about concurrency, we'll actually demonstrate some of the caveats on doing asynchronous event processing in the context of a UI, because there's some single-threaded UI loop sitting behind the scenes here.
That's right.
So actually this was a more complex query that you've actually seen here. So one more thing we could do is we could delay the whole thing just to push it a little further here. Let's say that we want to have this statistical information, but just delivered to us, 5 seconds after the fact. I can basically delay the whole sequence, and now I can move the mouse like crazy over here.
And after a whole bunch of seconds.
And after a whole bunch of seconds, you see 82. I haven't done anything the last second, but now you see it's actually going down to 0. And now I could start moving again. It will take 5 seconds for that event to be delivered to us.
That was that time shift you saw earlier.
That's the time shift you saw in the slides, exactly.
Yes.
Yep. So those are some of the interesting query operators. There are many more. I don't know how many we have, like 50 or so, or even
A
more.
lot, yeah, quite a few.
So there's a lot of stuff
And you
to
can
play
read the
around
docs
with.
to find more about
We
it.
have docs on MSDN.
All right, so the challenge for this this episode is to extend the previous challenge. So let's see here. We've got writing queries. So, oh, spoiler alert. So this is actually one possible answer you could have used for the previous example. So we have the text change and get suggestions here, and in the challenge, what you need to do now is update this in order to call things to, let's see, to avoid looking up for suggestions, the same suggestion twice, and also to wait till the user pauses at least 200 milliseconds. And so we have a hint about which type of operators to look at. There's lots of ways to do them. You don't have to do them the way we've described. And also the second thing you want to do is eliminate a race condition here that's caused by out-of-order arrivals. And so you want to look at the docs possibly to figure this out, talk to your friends, work it out, have fun, and post your solutions online. And you don't have to follow our hints. You can do what you'd like. So have fun, and we'll see you next time.